Hey, PropStat students, Mr. Mitchell here. We're going to start taking a look at sampling distributions, what a sampling distribution is, some notation with it, and where it's going to lead us. All right, so let me share my screen with you, and let's take a look. So we're talking about sampling distributions. We're also going to talk about the central limit theorem in our next video, our next section. All right, so we just need to review some terms first. What's a population? A population is everybody or everything within a specific group that we're interested in. A population can be a large group or it can be a smaller group. You could say the population is everybody within a certain family, or it could be everybody in the United States, or it could be a certain group within a community in the United States. Okay, so it doesn't have to be a huge number, or it could be a really, really big group. So it just depends on the situation. A sample is a subset or a subgroup of the population. Okay, so of the United States, you could sample people throughout the country, or if you're talking about Carlisle, we could pull a sample of people from Carlisle. If we're talking about the lacrosse team, the population would be the lacrosse team, and then we could sample people from the lacrosse team. So it just depends on what the population is, and then the sample is a subgroup. A parameter is any information or any number that's coming from the population. Okay, P and P, population parameter. A statistic is any number or any information that's coming from a sample. So you can have a population mean, you can have a sample mean. We use different notation to represent those. We'll look at those here in a minute. We can have sample standard deviations, population standard deviations. So it just depends on what are you talking about and whether it's a population or a sample, whether you call it a parameter or a statistic. Okay, just reviewing some terms there. So population, there's the formal definition, and then there's a sample, a formal definition there. Okay. A numerical description, measure of the population. And the statistic is a numerical description, measure of a sample. All right, so P and P, S and S. That's the way you remember it. Okay, so here's some notation. There's other things that we could look at. Pretty much for our class, this is what we're going to focus on. We have a mean of a sample, that's X bar. We have a mean of a population. So in math, we try to create symbols so we don't have to write out words. So instead of writing the sample mean, you just write X bar and that means sample mean. Instead of writing population mean, you write mu. It's a fancy looking U, we call it mu. All right, it's not an M, it's a U looking shape, okay? So don't write it as an M. If you're gonna write it as anything, write it as a U, okay? Standard deviation, we have S, that's a statistic, it's for a sample. We have this circle with a little curly Q, that's sigma, okay? Then we have variance. Variance is just the standard deviation squared. Whether it's a population or a sample, you're just squaring the standard deviation to get the variance. And then a proportion, we typically use proportions when we're dealing with categorical data, qualitative data, and we have P and P hat. So P hat represents a proportion from a sample, and P represents a proportion from a population. Okay, so again, a lot of information being communicated. We need to know the samples because we're not going to write this out. Okay, we're trying to write less, especially in math, and many times you don't want to write it. You don't want to write everything out either. Okay, we create little acronyms of things so we don't have to say every single thing. Same thing in math. Okay, so that's one of the things we create. So we use a statistic to make inference about a population parameter. So why don't we just forget about statistics and just analyze the population of everything? Because we don't have the time and the money to collect the data on the population. And sometimes even if we did have the time and the money, it's very inaccurate or it's constantly changing. Thinking about the population in the United States, there are babies being born as we speak. And unfortunately, there are people passing away as we speak. So our population is constantly changing. And people are constantly getting older. Like right now, today is somebody's birthday as well. So they're a year older. So if you're thinking about different age groups, those things are constantly changing day by day. So to get all that information and know exactly what it is for a population isn't realistic when you're talking about bigger, larger groups. If you're talking about maybe a smaller group like the basketball team or lacrosse or football team of a school, you can find the population information quite easy if you only have 20 people or even 100 people. But when you're talking about thousands and hundreds of thousands and millions of people, it's hard to find the parameters of all those groups. So what we do is we take samples to try to infer about the population. That's kind of the idea, all right? Sometimes we're going to estimate the value of the population from a sample, all right? And then we formulate decisions from that information, all right? There's a lot of people that have jobs that are taking sample data and applying it to populations. Sometimes they are spot on and sometimes they're a little inaccurate. The repeating of the process sometimes is what needs to happen to make them more accurate. Okay, so we'll get into a sampling distribution, a probability distribution for a sample statistic we are using. All right, so let's look at, this is the best way I can describe a sampling distribution. So here's the population of everything that could possibly happen. All right, so you have a mean of 16, the median is 16. So let's just say this is the average. I don't know, the background doesn't necessarily matter. Think of any example. This is the average, and then the standard deviation is 5. We just got done looking at normal distribution. So the standard deviation, you'd add 5 to go to the right 3 standard deviations. You'd subtract 5 to go to the left 3 standard deviations. So you could figure that out. The first standard deviation goes to 11, and then it goes to 6, and then it goes to 1. And then going this way, you go to 21, 26, and then 31. So you're adding to go to the right, subtracting to go to the left. So what a sampling distribution really is. All right, so we're going to take a sample of 5. And there you go. That's a sample of 5. So let me clear it and start over. So we're going to take a sample of 5 people. Okay, let's just say they were ages of people. All right. So there's the first person, second person, third person, fourth person, fifth person. So there's 5 people in my sample. And so there's the average of that 5 people. Well, then let's do it again. So 1, 2, 3, 4, 5. And then, okay, there's the average of those 5 people. And then you're going to do that. So you're going to keep sampling 5 people. You're going to sample 5 people, find the mean. You're going to sample 5 people, find the mean. Sample 5 people, find the mean. And you keep doing that. Okay, and that's the idea of a sampling distribution. It's all possible outcomes that we could get, all right, of sample 5. All right, can we change the sample size of 5? Absolutely. We're just kind of focused on this right now. So you can see the average is changing. Notice we had one person that was really low, but the average was still here. So we keep taking that of sample 5, and so let's do that a bunch of times. I just did it 10,000 times in the click of a button. You can see, notice this is the sampling distribution. This is the population. This is everything that could possibly happen. All right. And this is what's happening as you sample. So notice, let's do another 10,000 and another 10,000. Let's do 100,000. Let's do another 100,000, another 100,000. Notice I'm up to 330,010 people that I've sampled. Okay. So you can see what's happening here. Our average is kind of what it's supposed to be. Look at the average, 16. Okay. And then a standard deviation, notice, is less than 5. So a population, a lot more can happen with one thing in a population. That's really what this is, one thing. But when you average 5 people together, you don't have as many outliers. You don't have as much spread because you're averaging. Like, think about it. If I go fishing, and maybe this isn't a good example, maybe it is. If I catch 5 fish, the average of those 5 fish is probably going to be somewhere in the middle of what the average fish length or weight would be. I could catch one fish that's humongous, or I could catch one fish that's really, really small. But when you catch 5 fish and average them, the large fish and the medium-sized fish and the small fish, they kind of average themselves out. That's kind of what's happening here with the sampling distribution. Again, this is just single sample, this is everybody, the population, everything. This is a sampling distribution of 5. So let's just change our sample size and we'll start over here. And so we're sampling 25 people, sample size of 25. So I know it takes a little while. I'm not going to do this many times. But so, okay, there's one sample of 25. That's the average of that 25 people or things. Okay, so we could do it again. I'll do it one more time just to show. So these are the individual people that are being sampled. And then once you get to 25, there's the average of those. So if we do 10,000, notice I did 10,000 of those of sample size 25, and then do another 10,000, another 10,000. Notice, look at the mean, 16. We did 10,000 or 100,000, another 100,000, another 100,000. Look, it's not changing. The shape's not changing because it's averaged out to where it's supposed to be. And notice the spread is much less. And notice the spread is much less than it was when we did just a sample size of 5. When you average 25 people together, the bigger and smaller, or the older and younger people, for dealing with ages, are going to average out, and the people in the middle are going to average out, and the mean is going to be where the mean is supposed to be compared to its population. Again, look at the sample mean with the population mean. Okay, so that's really what a sampling distribution is. It's everything that could possibly happen in a sample, but when you start sampling of a certain size and you average that, you're going to cut down on your standard deviation of what could happen, but the mean is going to be where it's supposed to be. All right. So some of the key things that we need to make sure that we are focused on in this is understanding what a sampling distribution is, and then knowing our terms and knowing our symbols, our abbreviated symbols here that we use to represent things. All right. Let me know if you have any questions.